Welcome everybody to Algebra 2, Section 2.5, Solving Systems by Elimination and Application. So eliminations are third and final method for solving systems of equations. In 2.4 we covered solving them by substitution and graphing. Now today's going to be elimination, and similar to substitution, it's an algebraic method, one where you're not using visual stuff like a graph, but rather you are just using straight math and equations in order to get there. And some steps that we're going to follow are 1 through 5 here. 1, line up the equations, and by that it means we want them both in standard form or similar to standard form. And by similar to standard form, I just mean they're the ax plus by equals c, but we don't necessarily have to make sure that there's no decimals or fractions, or we don't have to make sure that a is positive, and we don't have to make sure that we have no common multiple other than 1. Not common multiple, but common factor. And so we just need the x and y on the left, and the constant on the right is really what we need. So step 2, multiply one or both equations by a number to result in a variable with the same coefficient. This is a sometimes have to do step, but not an every time have to do step. Same thing with 1, sometimes it's done for you. Step 3, add or subtract the equations to eliminate this variable, hence the name of the method, elimination. And then we solve for the remaining variable at that point. And then from there, step 5 is actually very similar to how we finished substitution. So in substitution, once we found our first variable, we just plugged it back into either equation of the original 2 to solve for the other one. And the same thing's true here on elimination. Elimination is basically just a new way to for the first 4 steps to solve the first variable. Once you find that first variable, the ending to find the other variable is the exact same as substitution. So here I'm actually going to start off with number 2 and then go back to number 1. So we're going to solve the system of equations by elimination and identify our solution, which will once again be an ordered pair. So here I notice that these are already lined up in x, y, and then the c on the end. So they're both in ax plus by equals c form. So I like to think that once again x, y equals number. Everything's very vertically lined up. And this method requires everything to be vertically lined up, which means that we need to have a good level of organization in this. And I'm going to be talking about different organizational tips throughout these different problems that I use to help you with that. So here, as we look at these, we want to make sure that if we were to add these equations together, just adding vertically common or like terms, that we would eliminate or get rid of a variable. Now what would cause that to happen here is we notice 5 plus 3 would be 8. That wouldn't eliminate or get rid of it, but 2 plus a negative 2 would give us 0y, thus having us have no more y's, because you'd have 0y, which once again really is just 0, because 0 times anything else is 0. And that eliminates or gets rid of a variable, which is our goal from this method. If you don't eliminate a variable, you're doing something wrong. Now, in order to make sure that we are going to eliminate a variable, we need to make sure one of the variables, either x or y, that the coefficients of the equations are the same numbers. So these are both 2, for example, and we want the signs to be different. One's positive, one's negative there, because then when you add the same number with different signs, you end up getting 0. They undo each other, they eliminate each other. So here we're ready to go ahead and add here, but if you're not ready to do that, if they're not the same numbers with opposite signs, then you have to do the step 2 from above, where you multiply one or both equations. Here I can go and add them though, and I'll get 3x plus 5x is 8x. These once again eliminate, like we mentioned, and get 0y, and I don't have to write plus 0y or plus 0 because it's the same thing as 8x. And then I write equals, and I add up on this side as well and get 64. Now I have this new equation, 8x equals 64. And similar to when we substituted, when we did that method in 2.4, we found the first variable by making an equation that we could then solve. And we made an equation that now we can solve for x by dividing by 8. And we get x equals 8. And there we have it. I already found the first variable. Now, in order to find our second variable, in this case y, we have to plug it back into either of the original equations, and we get our pick between the two. I'm personally going to pick the one with the smaller numbers and give us 3 times 8 minus 2y equals 22. And as I do 3 times 8, I get 24 minus 2y equals 22. I will subtract 24 and get negative 2y equals negative 2. And dividing by negative 2. I wrote negative 1. I was getting ahead of myself. Y equals positive 1 there. Oh, my apologies. This should have been a positive 2 the whole way. I messed up there. So let me go back and fix that here. This up here where it's negative 2y should have been a positive 2y. So let me go back and fix that. I guess I can just add in a plus sign there. My apologies on that. So it'd be a positive 2. So we divide by a positive 2, not a negative 2, which would create a negative 1. And so then our final answer, x comma y, is 8 comma negative 1. And so elimination was just a new way to get this first variable. But then once we got the first variable, this is all the exact same things we did last time in substitution to find the second variable. Now let's go over to example 1 here. I want to do this 1 second here because everything is lined up still, x, y equals, and the number signs. So everything's still in that exact order we want it, ax plus by equals c. But here, we notice these are both positive 1x's. And so if we were to add these, we'd end up getting 2x plus 6y, when in reality, we want one of those to be a 0x or a 0y. Now, those x's are very close to getting us to 0 because if one of those was a negative, then they would eliminate and we'd have no more x's, and that would be ideal. And at the end of the day, we don't really care which one of them is negative as long as one of the two is negative. And so up above it said you could add or subtract. And so this is when you would subtract. Now you got to be really careful here when you subtract that you're subtracting everything. And so it can be hard for us to remember that we're doing x minus x is 0, and then 7 minus negative 1 is really adding, and that's 8. And that can just get really confusing to carry the negative through. So instead of showing it as subtraction, I like to personally showcase it this way, to where I'm going to multiply this equation by a negative 1. And notice I put the entire thing, the entire equation in parentheses, not just one side, because I have to multiply everything in the equation in order to be fair, both sides. And so I multiply everything in one of the equations by negative 1, and I end up getting negative x plus y equals positive 7. And now if I were to combine this x with this negative x, that would work out exactly how I want it to where it eliminates. But as I mentioned earlier, it's very important for this method that everything is vertically lined up and organized. And so what I'm going to do is I'm just going to bring this equation over, and I'm just going to write it again using arrows to showcase where I'm going and where I came from. And now I have this organized just how I wanted it. X's, y's equals numbers, but I have these ready to eliminate. And so I can go and add and eliminate, and now I don't have to worry about keeping track of negatives as much as I did prior when I was trying to subtract, because the signs are already specific to their numbers now, specific to the terms, the x, y, the numbers. Now, if I had made this top equation negative instead, that'd be perfectly fine as well. You would have no difference in your answer. All that would happen is that when we add here, we get 8y. If you did the other way around and multiply the top equation by negative 1, you get negative 8y. And the bottom, on the right side, we get 24. If you did the other way, it'd be negative 24. So it'd just be negative 8y equals negative 24. The signs on both would just flip-flop. So here now we divide by 8, and we get y equals 3. And so we found one of our variables, and now it's time to find our other variable by plugging it into either of the original equations. You could technically plug it into this new one here that we modified. However, I encourage against that for the same reason as I encouraged against that in substitution, because there's a chance we made a mistake there where the original equations should be good and set to go. So I'm going to plug it into this bottom one here because there are smaller numbers there, and I'm going to do x minus 3 equals negative 7. And so I add 3 to both sides, and I end up getting x equals negative 4. And so this is the ordered pair, negative 4 comma 3. Now let's go on to example 3 here. These are still lined up correctly. X, y equals numbers. That's the first thing you should be checking for when you're doing elimination. And now if I were to add these x's, I would get 5x. And if I were to add the y's, I get negative 4y. And neither one of those eliminate how I want it to. So then the question becomes, okay, can I multiply one of those coefficients to make it the same number but opposite sign as the other one? And 5 times no easy number will get us 9. And by no easy number, I mean it would be a fraction rather than an integer. And 9 times no easy number would get us 5. 4 times no easy number would get us 1, but 1 times an easy number would get us 4. And so that would be the one that we want to try to target to eliminate. And similar to substitution, we could really pick any of these to try and multiply by, but it would just be harder. So here, for example, I'd have to multiply both 9 and 5 and multiply both equations to get them up to a common number, a common multiple, such as 45. But if I just multiply this bottom equation by a -4, I'm emphasizing that it's negative because I want this to be the opposite sign as what's above. And because the top's positive, I need this bottom one to be negative. And so multiplying that entire equation to get -4x minus 20y equals -16. The top equation, I'm good with how it is, and so I'm just going to rewrite it over here to once again keep my organization and everything vertically lined up. Now if I add these, my x's eliminate how I wanted it to. I get -29y, and I get -58. Dividing by -29 to get y by itself yields y equals 2. So now I plug it into either of the original equations. I'm going to pick the bottom one since, once again, smaller numbers. You'll notice that's a theme for me. And so I do x plus 5 times 2 equals 4. And that results in x plus 10 equals 4. Subtracting 10 rather, gives us the answer of -6. I got ahead of myself there. And so we end up having -6 comma 2. On the number 4 here, everything's lined up. Once again, x, y equals number. If it's not lined up, then you have to add and subtract things around from one side to the other to get them lined up in the order x, y equals number a, x plus b, y equals c, that standard form. And so here, I notice 7 times 2, or excuse me, if I combine these, I get 9. If I combine these, I get -9. Neither one of those is 0, so neither one eliminates. And 2 times nothing would get us 7, and 7 times no integer would get us 2, but 3 times an integer would get us 6. And so because this is a -6, I need this one to be a +6. Or I could change this to a positive and change this to a -6. But since I'm already going to be changing the bottom one here, I'm just going to go ahead and multiply this by a -2 and just change the sign and the number. That way I can keep the top equation the same. If you wanted to, though, change that top equation by multiplying it by a -1 and change the bottom one by multiplying it just by a +2, that's certainly available to you as an option. But I'm just going to once again choose this because now I'm only changing one equation, and that's less opportunities for me to make mistakes. So I'm going to go ahead and add, and I'm going to get 3x, 0y, they eliminate, equals -27. And now we divide by 3 and get x equals -9. So now I plug this into either of the original two, and I'm just going to pick the bottom one because, once again, the numbers are smaller, and I'm going to pick that every time unless I'm talking about my bank account. So we get -18 minus 3y equals -13. Adding 18 to both sides gets us -3y equals 5. And I go to divide here by -3, and I get a fraction, -5/3. And even though the 3 was negative technically in this fraction, it doesn't matter whether we keep the negative on the top of the fraction, bottom of the fraction, or out in front as I did there. You could also make this a decimal -1.6 repeating, or the mixed number -1 2/3. Now I got my ordered pair here of -9, -5/3. So it is very possible to get fractions here for one or both coefficients. In this case, just one of them. On to number 5 here, once again, everything is lined up. X, y equals numbers. That's good. Now we check to see if things would add and eliminate. We get 7, and we get 10 if we add, so neither one eliminates. 2 times nothing gets us 5. Same thing the other way around for 5 times nothing gives us 2. 7 times nothing is 3, and 3 times nothing is 7. So here we have to multiply both equations in order to get either the x's or the y's to a common multiple. Now, the thing is you have a lot of choice here. So I could choose to either get my x's up to the common number of 10, and so I'd multiply one equation by a 2, one equation by a 5 in order to get that to happen, with one of those being negative, so that way they'd be opposite signs. Or I could choose to get 3 and 7 up to a number such as 21 would be the smallest, multiplying the top by 7 and the bottom by 3, one of them being negative, the other being positive, in order to have opposite signs. And so I get to choose, do I want to multiply by 2 and 5 to eliminate x's, or do I want to multiply by 7 and 3 to eliminate y's? And of those two choices, I'm personally going to pick the one with smaller numbers. You notice that theme again there. So I'm going to choose to multiply the top equation by 2 and the bottom equation by 5, with one of those being negative. And whether you pick the top or the bottom one to be negative doesn't matter in the slightest. So I'm just going to go ahead and pick the top one to be negative. That way I'm changing this number to be positive. But once again, it really doesn't matter. So as I distribute negative 2 to the top equation, I get negative 10x minus 6y equals 14, and I get 10x plus 35y equals 15 on the bottom one. I should also note, if you would prefer, you could add an extra parentheses here to do this and write negative 2 multiplying on both sides individually. If that is easier for you to think about it, or better for you to think about it, or more straightforward, go ahead and do that. Otherwise, if you prefer to do it how I've been doing it, that's perfectly fine as well, of course. So adding these, the x's eliminate, and we get 29y equals 29. Dividing by 29 yields, or results in, y equaling 1. I'm going to plug this back into, I guess, the bottom equation. They're pretty comparable as far as positives or smaller numbers, although this one has a negative and the bottom one doesn't. So I'll do the bottom one. But once again, it really doesn't matter which equation you plug it into, as long as your math is correct. So I'm going to get 2x plus 7 equals 3. Let me redo that plus 7. That was pretty poor, even for me, and that's saying something. Subtracting 7 gets 2x equals negative 4. And then dividing by 2, I get x equals negative 2. So that results in the final answer of negative 2 comma 1. Number 6 here, everything's lined up again. X, y equals numbers. Nothing would eliminate though. I'd get 7, and I'd get negative 21. And 3 times nothing is 4. Same with the other way around, from 4 to 3. 9 times nothing is 12. Same the other way around, from 12 to 9. So I notice, okay, well, I could get 3 and 4 up to 12. That'd be their least common multiple. So I'd multiply 1 by 4, 1 by 3, one of them positive, one of them negative, to make them opposite signs, as they're currently the same sign. And with the y's, if I were to multiply 9 and 12, I could get them up to 36. And I can multiply the top one by 4 and the bottom one by 3. And we notice, wait a second, these numbers are the same this time. Both scenarios would be multiplying the top by 4, bottom by 3. In both scenarios, one of the signs would be negative and one would be positive. We don't care which one. So that seems odd. So let's just plan on multiplying by our only option, or the same option, where we multiply the top by a 4, the bottom by a 3, and we pick one of them to be negative. This time I'll just pick the bottom one to be negative, just because I picked the top one last time to change it up. So I get 12x minus 36y equals 36. On the bottom I get negative 12x plus 36y equals negative 108. And as I go through and add here, I notice the x's eliminate, the y's eliminate, but on this right side we end up getting negative 72. Now on that left side there is technically a number still, because you had 0 x's and 0 y's and 0 x's and 0 y's. That would be really just 0 times x is 0 and 0 times y is 0, and 0 plus 0 is 0. And so you're left with 0 equals negative 72. And so whenever you have an equation that has no variables, we ask whether it's true or false. In here, this is clearly false. 0 does not equal negative 72. They're not the same thing at all. And so it's no solution. Just like we've had with parallel lines being no solution, or substitution, we've came across that as well. Here in elimination, these two lines are parallel. They will never, ever, ever touch. Now, if you were to have 0 equals 0, for example, instead of 0 equals negative 72, then these two lines would have been the same line, and thus it would have been infinitely many solutions. Let's move on to the next page here. We're going up to number 7. Number 7, as I look to make sure everything's lined up, we notice, ooh, x and y, those are different, okay? Y and x, those are different, and the numbers come last together. However, the equal signs are also very much so not aligned. So I need to move this x over here, so both x and y are on the left. And so I'm going to subtract 2x in this bottom equation and get negative 2x plus 7y equals 8. The top equation, I'm keeping the exact same order because I want the x and y's on the left as they currently are. So that was an extra step we had to do here on number 7 that we did not have to do before. That'd be step number 1 from our 5 steps before at the beginning of the lesson. And so now here as I look at this, I say, okay, if I were to add 5 and negative 2, that gets me 3, negative 6 and 7 give me 1, and neither of those eliminate. So we need to multiply one or both equations. Well, 2 times nothing's 5, same for the reverse order. 6 times nothing's 7, same for the other way around as well. So I have to multiply both equations. So I can multiply 2 and 5 up to 10 by multiplying by 2 and 5, not changing the signs because one's already negative, one's already positive. Or I could say instead I'll multiply the 6 and the 7 by each other, 7 and 6, to get up to 42. And I'm going to choose 2 and 5 because the numbers are smaller. I wouldn't have to change the signs on the y's either because one's negative, one's positive. So I'm going to multiply by a positive 2 and a positive 5. Once again, drawing more arrows, just saying, hey, I'm going to continue to keep this organized. I'm going to continue to keep everything lined up vertically because it's so important here, but I'm going to be moving from the left to the right. So 10x minus 12y equals 6, and then 10x, negative 10x, plus 14y, sorry, try that again, 35y equals 40. And now as I add, the x's eliminate, and we get 23y equals 46. And so if I divide by 23, we get y equals 2. Now I can plug this into either of my original equations. Once again, I prefer the original just because they're less likely for us to make a second mistake. And so I'm going to plug it into, I don't know, this one. It doesn't really matter one way or the other. So I just picked one randomly. Once again, you might just pick based on the size of the numbers, the symbols you see as far as positive, negative, which side the variables are on. But here it's pretty, either way is just about the same for me on this one personally, but you might have a preference that's very clear on this problem. So now I multiply and I get negative 12, so 5x minus 12 equals 3, and I add 12 to get 5x equals 15. And last but not least, dividing by 5 results in x equaling 3. And so I now have my final answer of 3, 2 for my x, y. On number 8 here, we notice things are not lined up. The x's are on the left but not lined up. The numbers are on the left, the constants, which they're not supposed to be, and the y's are on the right, which is not where they're supposed to be either. And so I could either move both the y in each equation to the left and the numbers to the right, or what I could do is in both equations, I could just move the x to the other side, and then my variables are on the same side again. And so I'm going to do that. So I'm going to subtract my 10x from both sides in this equation, and then I'm also going to flip the equation around because it's the same thing to say 18 equals negative 10x minus 8y as it is to say negative 10x minus 8y equals 18. And I'll do the same exact thing in the bottom equation, but this time just subtracting 9x and get negative 9x plus 5y equals 4. And now I have everything lined up like I should, so I check to see if I add, will I eliminate? 9, that would give me negative 19, that would give me negative 3, so I don't eliminate. So what could I multiply 9 and 10 both to? Well, I could multiply both of those by each other and get up to 90. Whereas here, I can multiply by 5 and 8 to get up to 40, and of those two, I'm going to pick the smaller numbers. Plus, these are already opposite signs, so I don't have to change either sign. Where here, they're the same sign, so I have to multiply by a negative on one of them. So the top equation I'll multiply by 5, the bottom equation I'll multiply by 8. If you pick to multiply by 9 and 10, by the way, that would be perfectly fine as long as one's negative. So we get negative 50x minus 40y equals 90. On the bottom equation, we get negative 72x plus 40y equals 32. So adding these gives us negative 112x, y's eliminate, and we get 112. Dividing by negative 112 results in our x equaling negative 1. Plugging that into either of my original equations, I'm going to go and pick the bottom one since the numbers are smaller and get 4 plus 9 times negative 1 equals 5y. So now as I continue this problem here, I will get 4 plus a negative 9 equals 5y. Then I will combine to get negative 5 equals 5y, and dividing by 5 to get y by itself equaling negative 1. So this gives me the ordered pair of negative 1 comma negative 1. Now as I plugged it back in, notice since these equations were already solved for y, we kind of saved a step there where we didn't have to move things from one side to the other until we divided. So that's kind of convenient. So that wraps up the elimination portion, and now we're going to talk about the application portion, where these are going to be word problems. And these can be solved by any method we so choose. I typically prefer to solve them by elimination when I have the opportunity, but I'm going to be showing some from each method throughout this page and the next couple of pages of extra problems for word problems, for systems of equations. So some good steps, it can be really helpful to start by defining your variables, making sure we know what we're solving for. And just like in our equations we've done previously, examples 1 through 8, our variables are what we solve for, what we find. And so in the word problem, whatever you're trying to find will be your variables, your x and your y, if you will, or you can call them whatever letters you want. So here, Marcy bought a total of $20 or 20 used books and CDs during a yard sale for a total of $54.50. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? So that question there, how many of each did she buy? I automatically have alarm bells going off in my head when I see that question mark saying, oh, how many of these did she buy? Those are what we're looking for. So one variable is going to be the number of books, where the other variable is going to be the number of CDs. And so if you want to, you can use like B for books and C for CDs, or you can just use X for one and Y for the other. It's really up to you, however you do it. And so now that I know that those are my two variables, I can try to work on setting my equations using the information that's given to us. Now that can be much easier said than done. And so one thing I like to look for is I like to look for the labels on the numbers. So I look for the numbers and I say, what do those numbers tell us here? So here's 20 used books and CDs, $54.50. So $1 is what it's talking about, $1.50, and $5. And if I see three of the exact same label, so I see dollar, dollar, and dollar. So I see three numbers with the exact same label, not four numbers with the exact same label, not two with the exact same label, but exactly three. That's a big hint that those are typically going to be in an equation together, those numbers. And that'll be the case here as well. And we're told it's a total of $54.50. So that word total does a lot of work there, telling us it's going to be equaling $54.50. Now, be conscious here of the format a lot of these have come in, these systems of equations. We've had them in like ax plus by equals c format today. And that's going to be very, very common for word problems to have in this format. Not that it'll happen every single time, but it'll be very, very common for it, the most common one for sure. And so we're going to be looking for something in that format more than likely, which is the case here as well, where it totals the number 54.50. And so if I know X are books and it's told books are $1.50 each, that means $1.50 for every single book is being paid for. And if CDs are $5 each, that means $5 is being paid for every Y CD. And to get the total of $54.50, I have to take the total cost of books plus the total cost of CDs and add those together. And now that's one of my equations. $1.50 for every CD plus $5 for every book gives a total of $54.50. Now, when you have one equation that was those three labels on numbers going together, your other equation is going to be looking for this other total number, and it totals 20 books. So I'm going to put equals 20. And how do I get 20, not books, but 20 books and CDs? Well, it says it right there, books and CDs. So I take the number of books, I take the number of CDs, and I add them together. And now I have my two equations. So now I'm going to go ahead and start solving here, and I could solve by any method I want. So I could solve by substitution, elimination, or even graphing. I don't have a graph available, so I'm not going to choose that one personally. You could get a graph if you want, but I'm just going to choose not to and save myself the time. For substitution, I'd have to solve for a variable, and for elimination, I'd have to multiply by the bottom equation in order to make either x be 1.5 or y be 5, but both of those would be negative for the x and y on the bottom. And so I'm going to go ahead and multiply the bottom equation by negative 5. That seems like a lot more straightforward to me personally. But once again, if you'd wanted to use substitution or multiply the bottom equation by negative 1.5, that's an option as well, of course. So 1.5x plus 5y equals 5450. This equation just remains unchanged. And the bottom equation, negative 5x minus 5y equals negative 100. Now as we add here, we get negative 3.5x, y's eliminate, and we get negative 4550. Dividing by negative 3.5, we find x, the number of books, to be 13. Plug it into either equation. The bottom one's considerably easier in my opinion, so I'm going to choose that. And I'd say 13 plus y equals 20. Subtract the 13, and we find y to be 7. So how many of each did you buy? Well, we don't want an ordered pair here because we're not looking for a corner on a graph. What we want are labels. So we have 13 books and 7 CDs. And that would be our answer. Number 10 here, Landon babysits and works part-time at the water park over the summer. 1 week, he babysat for 3 hours and worked at the water park for 10 hours and made $109. The next week, he babysat for 8 hours and worked at the water park for 12 hours and made $177. How much does Landon make per hour at each job? That question there, how much does Landon make per hour at each job? Those are the two things you're trying to find. So we're trying to find the babysitting wage, and we're trying to find the water park wage. And notice I abbreviated babysitting to babysit, and I abbreviated water park just water just to shorten them up. And I can call these X and Y, Y and X, B and W, whatever you want. And so now I look for those labels like I did on the last problem. And when I look for labels, I'm looking for the numbers and then what type of the number is it. So it's 3 hours, it's 10 hours, $109, 8 hours, 12 hours, and $177. So I notice I have 4 numbers that have the label of hours and 2 numbers that have the label of dollars. So it's not exactly 3 of any one label like I did on the previous problem, meaning we're not going to put all 3 of those numbers together in one of them. Instead, it's going to be a different setup and a different type of problem. So how we're going to set this one up is we know that this first or the second sentence where we're talking about the 1 week instead of the next week, the 1 week, we know that this combination, 3 hours and 10 hours of the 2 jobs, got $109. So that's going to be one of our equations. 3 hours of babysitting at that rate, so 3x, plus 10 hours at the water park at that rate, so 10y, gave us a total, or gave Landon a total of $109. And now my second equation is going to be that next sentence. We're talking about the next week, and the combination of 8 hours at the babysitting, or at the babysitting, at 8 hours babysitting, so 8x, plus 12 hours at the water park, 12y, paid him a total of $177. And now we have our 2 equations. Once again, I can solve this by any method I so choose. I just personally prefer elimination, so I'm going to be picking that multiple times here as often as I can. And if I multiply these equations, I have to multiply both here in the scenario because the x's won't eliminate currently and the y's won't eliminate currently. And I can't multiply 3 to get to 8, or 8 to get to 3, or 10 to get to 12, or 12 to get to 10. So I can multiply the x's up to 24, or the y's up to 60. And so I'm going to choose to multiply the x's up to 24 by multiplying by 8 and 3, respectively, top and bottom. And one of them being negative, I'll just go and pick the top one to be negative just because. So we get negative 24x minus 80y equals negative 872. And on the bottom, we end up getting 24x plus 36y equals 531. So as we add to eliminate, the x's eliminate, we we get negative 44y. On the right side, we get negative 341. Continuing here by dividing by negative 44. Y is 7.75. Definitely would like to use a calculator on this one, preferring to do that overhand, especially since we get decimals. But you also could do it by hand. And so that means Landon makes $7.75 at the water park. These numbers probably need updated due to current minimum wages, but previously that would have been not uncommon. Now I need to find the babysitting wage by plugging it into either equation. So let's just say I plug it into the top equation because the numbers are smaller here. So I plug it into this top equation, and I get 3 times x plus 10 times 7.75 equals 109. And so that results in it being 3x plus 77.5 equaling 109. Subtracting 77.5 gets us 3x equals 31.5. And dividing by 3 tells us that the wage for babysitting is 10.5 or 10.50. So to answer the question here, we will say Landon makes $10.50 per hour babysitting. And makes $7.75 per hour at the water park. And I could put at the water park, or I could do like an arrow saying this is for the first one, this is for the second one. Really, any way you want to phrase that is perfectly fine, as long as you clarify which one's which. You can even abbreviate water park to WP or babysitting to BS if you want. Number 11 here, Kent has a collection of pennies and nickels with a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? So how many of each coin does he have? We're looking for pennies and nickels, the number of each. We know the value of a penny is 1 cent, and we know the value of a nickel is 5 cents. But we don't know how many pennies or nickels Kent has. So I'm going to call pennies X, nickels Y. We call them like P and N, for example. And we know that when the total value of these coins is $1.98, and we don't have any other numbers listed here except for the number of pennies is 5 less than twice the number of nickels. And so we're going to be doing one equation for the first sentence and one equation for the second sentence. And so for the equation for the first sentence is going to be 0.01x, so a penny for every, so a cent for every penny, plus 0.05y, 5 cents for every nickel, would result in $1.98. The other equation, we're told the number of pennies he has is 5 less than twice the number of nickels. So if we take the number of pennies is or equals, and then the number of nickels, in order to get to the number of pennies, we take the number of nickels and multiply it times 2 and subtract 5. And that would give us the number of pennies on the left. And so now here we have our two equations. And I could do elimination, but I'd have to move my 2y over, and I had to multiply a bunch of stuff. And since I already have a variable solved by itself, I'm going to go ahead and do substitution and plug this in for x in the other equation. So I'm going to get 0.01 times 2y minus 5, sorry, not equals, but plus 0.05y equals 1.98. We're going to distribute this 0.01 and getting 0.02y minus 0.05 plus 0.05y equals $1.98, 1.98. Combining like terms on the left-hand side results in negative 0.05 plus 0.03, you can flip the order of those as well, equals 198. Now if I add 0.05 to both sides, I get 0.03y equals 2.03 or $2.03. Dividing by 0.03 results in y equaling 29, meaning Kent has 29 nickels. Now we have to plug this back into either of the original equations. I'm going to pick the bottom one because there aren't decimals and x is already solved for. And so I'm going to have x equals 2 times 29 minus 5. 2 times 29 is 58 minus 5, and 58 minus 5 is 53. So Kent has 53 pennies and 29 nickels. Now we get to move on and have the pleasure of doing 8 more word problems. And so for each of these, we're going to define variables, set up the system of equations, and solve. So number 1, at the fast food restaurant, 4 cheeseburgers and 5 small fries have a total of 2,310 calories. Oh boy. 3 cheeseburgers and 2 small fries have a total of 1,300 calories. Better, but still not great. And how many calories does each item contain? So hopefully no one person is consuming either one of these scenarios. But regardless, we want to know how many calories does each item contain. So one variable is going to be representing the cheeseburger calories. Need another E there for cheeseburger. I'm going to abbreviate calories to CAL. I'm going to call that one X. And the other one's going to be the fries calories, which I'm going to call Y. You can call them like C and F for cheeseburger and fries, for example, if you wanted. Or you call them just like S and Q, just for randomness, if you want as well, obviously. So here, as I look at labels, it's 4 cheeseburgers, 5 small fries, 2,310 calories, 2 small fries, 3 cheeseburgers, I went out of order there on accident, and 1,330 calories. And so I don't see any 3 of the exact same label on these numbers. Not more, not less, but not exactly 3 on any of these, so I only see 2 of each of these, which is not what I'm looking for. So I'm going to do each sentence is an equation. So the first sentence, 4 cheeseburgers, so 4 times X, and, so adding here, 5 small fries, 5Y, gives a total of, so equals 2,310 calories. Bottom equation is going to be incredibly similar, but it's 3x for 3 cheeseburgers and 2 small fries and 1,330 calories. So now on these, once again, I can solve by any method I so choose. I'm going to choose elimination here. Everything's lined up for it already. I would have to multiply both equations. I can either multiply these up to 12 or these up to 10. I'm going to choose to multiply by 3 and 4 rather than 2 and 5. And that's just a personal preference. And so I'm going to multiply the top one by a -3, the bottom one by a 4. You could switch those around to make the bottom one -4 and the top one +3. And so I get -12x minus 15y equals -6,930. And on the bottom one, I end up getting 12x plus 8y equals 5,320. So as I look to add here, the y's eliminate, or the x's eliminate, and I get -7y. And on the right-hand side, I get -1,610. Now, if I divide by -7 on each side, I find out that every small fry has 230 calories. Now I plug this back in to find the number of calories in a cheeseburger. The bottom one has smaller numbers, so I'm picking that one. And I'm going to have 3x plus 2 times 230 equals 1,330. If I multiply 2 times 230, I end up getting 460 that I'm adding with 3x to get 1,330. Subtracting 460 gets us 3x equals 870. And dividing by 3 tells us that a cheeseburger has 290 calories. So to answer our final question, a cheeseburger has 290 calories, and a small fry has 230 calories. And you could use the word has or contains if you wanted to in that as well, instead of the arrows. On number 2, 1 month, a homeowner used 150 units of gas, 520 units of electric, total cost of $84.20. The next month, 210 units of gas, 405 units of electric were used for a total cost of $82.35. Find the cost per unit of gas and electric. So find the cost per unit of gas and electric. So one is the gas cost, and one is the electric cost. You can call them G and E if you want. You can call them X and Y, which I'm going to do just out of being familiar with that personally, or that's just my tendency. If I look at labels, 150 units of gas, 520 units of electric, $84.20, 210 units of gas, 405 units electric, total cost of $80.35. So I don't see exactly 3 of any one label, I just see 2 of each label. And so I'm going to go ahead and look at these sentences as my equations. So 1 month, next month. So the first month is going to get its own equation where it's 150 times every unit of gas for the cost, so 150x, plus 520 units of electricity times the cost per unit of y equals 84.20. The other one is going to be 210x for 210 units of gas, 405y for 405 units of electric, and for a total of $82.35. Here, once again, I could use substitution or elimination. I love elimination, so I'm going to continue to pick that. If I multiply the x's by, or the top equation by 7 and the bottom equation by 5, I end up getting the x's to be the same number. You kind of have to just do trial and error there until you find a number that they can multiply up to if you do this method. Otherwise, you could always just use substitution and solve for a variable in one equation and plug it into the other equation. So I'm going to multiply the top one by a 7 and the bottom one by a -5. One of them has to be negative in order to change the signs, and I just happen to pick the bottom one here. So I get 1050x plus 3640y, I accidentally wrote x there, equals 589.440. In the bottom equation, I get negative 1050x minus 2025y equals negative 411.75. So I'm going to go ahead and add to eliminate, and my x's eliminate. My y's, we end up getting 1615y, and on the right hand side I end up getting 177.65. Now as I divide by 1615, definitely letting the calculator do some work here, and getting y to be 0.11. So it means 11 cents per unit. Plugging back into either equation to solve, my bottom equation is slightly smaller. So 210x plus 405 Sorry, I buffered there. I'm actually going to plug it into the top one here, even though the bottom one has a smaller number here and here. I like the 150 over the 210, and plus I already have it written down on my copy of the notes as a top one. And so for sake of not having a calculator next to me, I'm just going to go ahead and do it how I already have it written down. So apologies to anyone who's erasing here to follow my work, but if you plug it into the bottom equation, you'll still get the same answer. So I'm plugging it into the top equation here, and I multiply 520 times 0.11, I get 150x plus 57.2 or 20 equals 84.2 or 20. Subtracting from both sides, 57.2 gets me 150x equals 27. Let me try that again. Dividing by 150 tells us that each unit of gas costs 18 cents or 0.18. So to answer the question at the very beginning, gas costs 18 cents per unit, and electric cost 11 cents per unit. Moving on to number 3 here. Kim is renovating the first floor of her home, and she bought 750 square feet of carpet and 750 square foot of laminate flooring and 525 square feet of carpet, and paid $2,717.25. The stuff is not cheap. She went back to the store and bought an additional 100 square foot of laminate flooring and 75 square feet of carpet, and paid $374.75. She must have needed more to finish the job, or decided to do more in another room or something. And find the cost of the square foot of each type of flooring. So that's our question. That's what we're trying to find. So one, we're trying to find the cost of laminate, so laminate cost, and the other one we're trying to find the carpet cost, both per square foot. And so I'm going to call one X, one Y, or L and C, or whatever. And so as I go through here and I go through labels again, 525 square feet, 750 square feet, we got dollars there, we got square feet again for 100, 75 square feet, another dollars. So I don't see exactly 3 of the same label. I see 4 of one label and 2 of the other. And so now as I look through here, I'm going to say, okay, let's do the first trip she went to the store and the she went back trip, the second trip. So 750 for laminate, or 750 square foot, so 750X would be the cost of the laminate there, plus 525Y for 525 square foot of carpet at whatever cost that is, equals the total she paid that trip. Same thing on the bottom trick, but changing up the numbers to 100X plus 75Y equals 374.75. Once again, now that these are set up, I could either use elimination or substitution or graphing if I had a graph. And I'm going to use, a substitution, elimination. If I multiply the bottom equation by -7, my y's will be the same number, but opposite signs. So I only have to multiply one equation here, which makes me pretty happy. So the top equation stays the exact same. I must have forgotten a 5 on my 525. And the bottom, or the equal sign, is 2717.25. The bottom equation becomes negative 700x minus 525y equals negative 2623.25. And so if I add up here, I get 50x, my y's eliminate, and on the right side I end up getting 94 divided by 50. And the cost of laminate flooring per square foot is $1.88. Plug back into either equation. Let's do the bottom one here. Smaller numbers. And I get 100 times 1.88 plus 75y equals 374.75. So that's 188 plus 75y equals 374.75, which results in 75y equaling 186.75. Dividing by 75 tells us the carpet costs $2.49 per square foot. So as I write my answer, we know that laminate costs $1.88 per square foot. Which you could do this, or you could do, that's the same thing, foot squared, but we read it as square foot. So either abbreviation is perfectly fine, whatever you want to do. And the carpet cost $2.49 per square foot. Once again, flooring is not cheap. Sean bought 1.8 pounds of gummy bears, oh my, and 0.6 pounds of jelly beans and paid $10.26. He went back to the store the following week and bought 1.2 pounds of gummy bears and 1.5 pounds of jelly beans and paid $15.09. What is the price per pound of each type of candy? That's what we're trying to find. So one variable is going to be the price per pound of the gummy bears. So gummy bear cost. And the other one is going to be the price per pound for jelly beans. So jelly beans cost. You can do like GB for gummy bear and JB for jelly beans, or G for gummy and J for jelly. Or you can just do X and Y, as I often do. Here, we once again don't have any label that has exactly 3 on those numbers, and so we're going to do the trips to the store here. We notice a consistent theme in these first 4 word problems being the same type of setup, to where you do one equation for one sentence, another equation for another sentence. So 1.8x for 1.8 pounds of gummy bears plus 0.6y for 6.6 pounds of jelly beans gives us the total cost that Sean paid on that trip of $10.26. Second equation would be similar but changing out numbers. It'd be 1.2x plus 1.5y, really wanted more jelly beans on the second trip, equals 1509. Now I could either solve for a variable and substitute, or I could multiply one or both equations and eliminate. And if I multiply the top equation by 5 and the bottom equation by 2, I get the x's to both be, I get my y's to both be at 3. And I'm going to multiply one of them by a negative because they're currently both the same sign. So I'll say I multiply the top by a negative. And so I get negative 9x minus 3y equals negative 51.30. The bottom equation is 2.4x plus 3y equals 30.18. Now if I add here, let me change the color there, I thought I did. We end up getting negative 6.6x, the y's eliminate, and on the right side we end up getting negative 21.12. If I divide by negative 6.6 here, I find out the cost per pound of gummy bears is $3.20. Plug that back in to find the cost per pound of jelly beans into either equation. Here I'll go ahead and do the top equation and get 1.8 times 3.2 or 3.20 plus 0.6y equals 10.26. So this gets me 5.76 plus 0.6y equals 10.26. Subtracting each side by 5.76 gives me 0.6y equals 4.5. And dividing both sides by 0.6 gives us y being 7.50 or 750. So per pound, the gummy bears are, so I'll just put gummy to shorten it up, cost $3.20 per pound, or LB, whereas the jelly beans, which I'll just put jelly, costs $7.50 per pound. Trying to fix my dollar sign, but I think I made it worse. And so that would be our answer here. I forgot to box the answer number 3, so I went ahead and did that. Four more problems left here. So on number 5, Courtney has a total of 88 stamps worth $15.56, and some are 25-cent stamps while others are 2-cent stamps. We want to know how many of each does she have. So those will be our variables here. So we're looking for the 25-cent stamps, the number of them, and the number of 2-cent stamps. And so the number of 25-cent stamps I'm going to call X, and then the second one I'll call Y. And as I look at labels here, I see 88 stamps, $15.56, 25-cent stamps, and 2-cent stamps. Now these can be tricky because these have cent signs. You have to be careful here knowing that's just talking about that type of stamps. And so I'm going to put those three of the exact same label here, stamp, stamp, stamps, in one equation. So I'm going to have X for the number of 25-cent stamps plus Y for the number of 2-cent stamps equals 88 for the total number of stamps. Now this other number I have, 1556, I'm going to have that as my total I'm equaling it to. In order to get to that number, I'm going to do 0.25x for 25-cent stamps times how many I buy, 0.02y for the 2-cent stamps for how many I buy. Now, to make my problem easier here, since I know I'm having a bunch of decimals in this bottom equation, I can actually just put all of these in terms of cents. Instead of calling it 0.25, because it's 0.25 of a dollar, I can call it 25 for cents. And instead of calling it 0.02, I just call it 2 cents. And that on the right side, then I can't call it 15.56. I'd have to call it 1,556 cents. And that's essentially the same thing as if I were to multiply this bottom equation by 100, but doing so allows me to not have any decimals currently. And I'm going to go ahead and take advantage of that to make my life easier. But something you can do on every single problem that has decimals is essentially multiply by a power of 10, so 10, 100, 1,000, depending on how many decimals you need to move in order to have no decimals. And if I do this here, I can see now that I can multiply the top equation by -2, and now my y's are going to be the same number, different signs. So I get -2x minus 2y equals -176. And the bottom equation is just going to remain the exact same. Now, if I didn't do that little trick there where I changed these, the decimals, and I made it into cents instead of dollars, I still could get the right answer just by multiplying whatever I would or substituting instead. Now I get 23x, my y's eliminate, and I end up getting 1,380 on the right. So on the left, I end up dividing by, so on both sides I should say, I divide by 23. And this tells us that Courtney bought 60 25-cent stamps. And because we did both sides of the equation, here by multiplying by 100 or turning them into cents instead of dollars, I don't need to do anything with that 60 to make it the final number for x. It's already there. It's already the actual number. And so I just need to find y, which I can do by plugging in this top equation and saying they add up to 88. And so maybe you don't even actually have to plug this in order to solve. You can just say, oh, 60 plus blank equals 88 and have the answer and say, oh, it's 28. And so Courtney here bought 60 25-cent stamps. I'm going to put a little dash between the two. So 60 25-cent stamps and 28 2-cent stamps. And that'd be our answer. On number 6, Tom. Tom put 18 gallons of mid-grade gas in his truck and filled up his empty 5-gallon gas can with regular gas for his lawnmower at home. And he spent $59.91 to do so. The following week, he put 14 gallons of mid-grade gas in his truck and topped off his 5-gallon gas can with just 1 gallon of regular gas. If he paid $39.75 and the prices remained the same per gallon of each, find the price per gallon of mid-grade and regular gas. So find the price per gallon of each of these. So one is the cost of mid-grade, where the other one is the cost of regular. And so I'm going to call mid-grade X, regular Y. And as I look for labels, 18 gallons, $59, 14 gallons, and $39.75. So I notice none of these are give us three the exact same label. So instead I'm going to do the first week and the following week, that second week. And so the first week here, it was 18 gallons of mid-grade gas, so 18X, plus 5-gallon gas can. He filled it up. So 5y equals the total he paid, $59.91. The following week, it was 14 gallons of mid-grade gas, so 14x, and he only put 1 gallon of regular gas. That's a label I missed, it was 1 gallon there. So that'd be 1y equals $39.75. And so now I can multiply this bottom equation by -5, and my y's will be the exact same thing. You could also solve for y here and substitute it into the other equation if you would prefer to do substitution. I'm going to use elimination, like I mentioned, by multiplying the bottom equation by -5, so my top equation remains the exact same. My bottom equation becomes -70x minus 5y equals -138.84. As I go ahead and add to eliminate, my x's become -52x, my y's eliminate, and that right side becomes negative. Oh, my apologies. I did some math. I wrote down the wrong number earlier here. For that total on the right-hand side of the second equation, it becomes -198.75. The number I wrote down instead is actually what goes down here when we subtract those or add the positive and negative to get -138.84. Now as I divide both sides by -52, we end up getting x equal positive 2.67. Plug that back into either of these original equations. I'm going to choose here the bottom one, so 14 times 2.67 plus y equals 39.75. 14 times 2.67 is 37.38, plus y equals 39.75, and subtracting from both sides gives us y equaling 2.37. So that tells us that the mid-grade was my x, the mid-grade costs, I wrote the S in the wrong spot there, $2.67 per gallon, whereas the regular costs $2.37 per gallon. And that'd be my final answers. Let's look at number 7 here. A total of $12,000 was invested in 2 types of bonds. One pays 8% simple interest, while the other pays 10.5% interest. Last year, the annual interest earned on the 2 investments was $1,145. How much was invested at each rate? So how much was invested? So we want to know the amount in the 8% bond and the amount in the 10.5% bond. I'm going to call one X, one Y again. And here, as we look at labels, we have dollars, percent, dollars. So only two of each label here. So as I look at this first sentence, it's actually an equation. A total of $12,000 was invested in 2 types of bonds. So the amount of money in one bond was X, the amount of money in the other bond was Y, and that gives us $12,000. Now we know that the interest on those was $1,145. So 0.08%, so the 8% interest on the first bond plus 0.105, 10.5% interest on the amount in that second bond gives us a total interest for the first year, $1,145. Now, let's say here I went ahead and solved this by elimination, or say substitution this time, just to change it up a little bit. You could do this by elimination, by multiplying this by 100 or 1,000 to get rid of decimals, or multiplying these by a decimal if you want. But I'm just going to go ahead and solve this top equation for x by subtracting y, and again, x equals $12,000, 12,000 minus y, or negative y plus 12,000. Plugging that in here to my other equation, I would end up getting 0.08 times 12,000 minus y plus 0.105y equals, I'm running out of room, 1,145. So over here, as I distribute the 0.08, I end up getting 960 minus 0.08y plus 0.105 equaling 1,145. Combining those like terms of 960 and 0.105, I end up getting 960, or I'm going to go ahead and combine those and subtract it over at the same time. Oh, my apologies here. This was a y. So I'm actually going to combine these and keep the 960 there. My apologies on that. And so I end up getting 960 plus 0.025y equaling 185. So I'll try that again. 1,145. Subtracting 960. Now this is when I get the 185 on that side. And dividing by 0.025. I get y to equal 7,400, which was invested in one of the accounts, the 10.5% interest. And so now plugging into either of the original 2 equations, the top one's going to be much easier for me personally. So I'm going to do x plus 7,400 equals 12,000. Subtracting 7,400 from each side gives us x equals 4,600 or 4,600. So in the 8% bond, we had 4,600 invested, and in the 10.5% bond, we had 7,400 invested. On to our last problem here, number 8. A collection of dimes and quarters is worth $9.55. If the quarters were dimes and the dimes were quarters, the total value would be $7.60. Find the number of each coin. So that's our question. That's going to tell us our variables. So the number of dimes is one variable, I'll call it x, and the number of quarters is our other variable, I'll call it y. And labels here, we're just told dollars and dollars, so just two of one label. And we're going to end up doing this sentence for an equation and the second sentence for an equation. So dimes and quarters is worth $9.55. And similar to our problem here where we did the one with pennies and nickels on problem 11 of the actual 2.5 section, we're going to do 0.01x and 0.05y for pennies and nickels value. We're going to do very similar here, where we have 0.1x for 10 cents for a dime and 0.25y for 25 cents for a quarter equals 9.55. And we could move these decimals over and call this 10x plus 25y equals 955 if we wanted. For our other equation, we're saying, okay, now if the quarters were dimes and dimes were quarters, so if we flip-flop the amount of each, and then the total value would be 760 instead. So it'd be 0.25x plus 0.1y equals 7.60. So instead we had 25 cents for every dime because the amounts are switched, even though we actually have that many quarters. And so now as we start solving this one, I'm going to go ahead and solve this one by elimination here. So I'm going to multiply this top one by 5, the bottom one by -2. And what's going to happen is these are both going to get to 0.5 or 50 cents. And so it's going to be 0.5x plus 1.25y equals 47.75. On the bottom we end up getting negative 0.5x minus 0.2y equals negative 15.2. I could have multiplied the top by a negative or the bottom by a negative. I just happened to do the bottom by a negative on this problem. So the x's eliminate, the y's end up getting 1.05y, and on the right hand side we end up getting it equaling to 32.55. Dividing by 1.05, we end up getting y equals 31. So that's 31 quarters. And then we plug it back in to find the number of dimes. So I can plug it back into either equation. In this case, I'll just go ahead and plug it into the top equation. And 0.1x plus 0.25 times the 31 quarters we have equals 9.55. So that's 0.1x plus $7.75 from all those quarters equals 9.55. Subtracting 7.75 from each side, we get 0.1x equals 1.80, meaning there's $1.80 worth of dimes. So dividing by 0.1 for the value of each dime, that tells us that there were 18 dimes. So to answer our final question, we say that there are 18 dimes. Let me just rewrite that. Oh, that was pretty bad. So 18 dimes, and there were 31 quarters. And that wraps up Unit 2 of Algebra 2.